So fundamental trigonometric identities. So some of the basic identities that you'll see, or that we have actually talked about some of them already, is that sine of theta is 1 over cosecant theta. Okay. We've also seen that cosine of theta is 1 over secant of theta. And we said that tangent of theta is equal to 1 over cotangent of theta. Well, if you know these three, then there's three more you can create from this. Okay? There are three more you can obtain from this, because I can tell you that cosecant of theta will then be equivalent to 1 over sine of theta. Okay? You see that? And that's basically coming from here, right? If you know this, you can get this. Okay? Why? Because if we say that sine of theta, let's put that in blue. If we're saying sine of theta is equal to 1 over cosecant of theta, if you put this over 1 and you cross multiply, you will get sine theta times cosecant theta is equal to 1. And then if you divide both sides by sine of theta, this will cancel with this. All right, cosine. You will see that cosecant of theta is equal to 1 over sine of theta. Right? So that's, if you notice, that's the same thing I have there. Okay? So then, if we know cosecant, we can also say that secant, okay, secant of theta is equal to 1 over cosine of theta. Right? And you can take this one here and do the work that I showed and see how you end up with this. And then we also have tangent of theta, cotangent of theta, sorry. Cotangent of theta is equal to 1 over tangent of theta. So these are the 6 common ones, right? These are very common. And we also talked about, we said that tangent, this is called the quotient identities. We said that tangent of theta is equal to sine of theta over cosine of theta. We had said before that tangent is y over x. And remember, sine takes the y value, right? And then from this, we can say also, so here's another one you'll have to know. Cotangent of theta is the inverse of that. So that's cosine of theta over sine of theta. Okay. Now, the next two that I'm about to show you, so there's a whole bunch of these, right? There's a lot of them that you guys have to know. So, especially for folks who have to take Calculus 2, make sure you go over these and you learn them, okay? Because you'll have to know them. There's also the Pythagorean Theorem identity. Okay, which tells us very, very common, sine squared theta plus cosine squared theta is equal to 1. And from this 1, I can get 2 more. For example, if you take this here and you, if you take this and you divide it by sine squared theta, you'll get 1, right? So then I have 1 plus cosine squared theta divided by sine squared theta. Cosine squared divided by is tangent square, isn't it? So then this becomes tangent square theta, and 1 over sine squared theta. Well, 1 over sine we know is cosecant. Okay? Secant, sorry. 1 over sine is secant. 1 over sine square will be secant squared theta. Okay? 1 over sine, I have it somewhere in the top here. One over sine, yes. Why did I have that? Okay. So let me take this out. So that's how you end up with the second one. And then if you do the same thing on divide every term by cosine,
Professor,
one second. You will have another identity. Go ahead.
Is tan theta is sine over cosine, or is it cosine over sine?
Tangent is sine over cosine.
So when you divide by sine, wouldn't that be cotangent?
Yeah, I'm doing that one now.
But in the second identity, you have 1 plus tan squared.
Yes, sorry. Because I divide here by, you're talking I divide here by sine squared, right? Yes, so this will be cotangent squared. Thank you, Ahmed. So what happens now if we divide every term by cosine now? What happens if we divide everything by cosine? So if you divide sine by cosine, this becomes now tangent, right? Plus, if you divide this by itself, you'll get 1. And then if you divide this by cosine, you're going to get 1 over cosine is 1 over cosine. Where is it? Secant. So here we have, but since we're divided by cosine square, we're going to get, this doesn't something, secant square. Guys, there's an error here too. What am I doing? I don't know. This is supposed to be cosecant. Nobody's saying anything to me. Yeah. Now, generally you will see them written with the 1 first, or I can write 1 plus tangent squared theta is secant squared theta. So these are the identities you guys have to learn. Okay, 1, and there's a few more. 2, this is the main one. 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's a few more, but those are the 11 ones that we use a lot. Okay, more than any others for what we're doing. Okay, and then look at the online notes. We have some that's called co-functional identities, and then we have even and odd, because you have to know which of these function is even and which one of them is odd, right? So make sure you look at the functions then and see which is even and which is odd. Okay. Now, so why do we need them? Well, there's a bunch of reasons, because you guys have to know how to work with them. Okay. And you use them to help in section 5.2, we're talking about proving identities, because you want to rearrange them. Or you can also use them to help you find other functions, right? Let's look at this one here. Example. Use the condition secant of theta, and this doesn't have to be theta, right? This could be any letter to represent. So usually in my notes I have it as u is equal to minus 3 over 2, and tangent of u have to be greater than equal to 0, or greater than 0. Tangent can be 0. And then I want you to find okay. Well, if this is given, okay, something else is implied. What is implied? If you know secant of u is minus 3 over 2, right? You know this. So if you know this, what can you get from secant?
The cosine.
Cosine, right? This tells, because cosine of u is 1 over secant u, isn't it?
Yes.
Cosine, this one here, right? Okay. So if we simplify this, okay, this becomes cosine of u is 1 over minus 3 over 2, which is equal to minus 2/3 if you do the algebra behind this. So you have cosine, okay? You have cosine and you have secant, okay? Now we know, right? And this is where it gets now a little tricky. We also know, so we have to find the rest of them, right? So far we've got, what do we have? We have secant, we have cosine. So we need sine, we need tangent. Here we need cosecant, and we need cotangent. So those are the things we still have to find, because they said they want all 6 of them. Okay. Since they need all 6, we have to find those. Well, if you're careful, you know that sine of u, sine square u plus cosine square u is equal to 1. Okay. And this also tells you that sine squared u is equal to 1 minus cosine squared u. Do you agree?
Yes.
Right? If you subtract cosine squared on both sides, and we know cosine squared, at least we know cosine, so cosine squared will be take that number and square it. So we can say that sine square u is equal to 1 minus 2/3 square, which is equal to 1 minus 4/9, which is 9 over 9 minus 4 over 9, which is equal to 5 over 9. So we know that sine squared u is equal to 5/9. Okay?
Yes.
So sine, okay, sine of u will be plus or minus the square root of 5 over 9. Now we have to be careful, okay? We have to be careful because conditions were given here also. Tangent is greater than 0, and secant, which comes from cosine, is negative, right? So what does that tell us? Remember, all students take calculus, right? So what do we have? We're saying it's giving that tangent is greater than 0. I mean, tangent is positive. The only place tangent is positive is here and here. Do you agree? Only 2 places. In addition, they're telling us that cosecant, which comes from cosine, is negative. So where is cosine negative? Has to be in this quadrant here, because cosine here is also positive. So we're talking about quadrant 3. We're talking about quadrant 3. This thing is in quadrant 3. Okay. Now in quadrant 3, is sine positive or is sine negative? Okay. So because you have to know, is it positive or negative? So since we're in quadrant 3, this implies in quadrant 3, okay, sine is negative. So the correct answer is sine of u will be negative, okay, radical 5 over 3, or minus radical 5 over radical 9, or minus radical 5 ninths square root. But which one is better? This one here is the preferred answer. So we've got our sine. Which one else is missing? And if we have sine, we know cosecant, right? So sine, we just say, is minus radical 5 over 3. Then this here is 3 over minus radical 5, which is equal to minus 3 radical 5 over 5. This is the answer you have to present to me. Now let's go see if we can figure out tangent, okay? Tangent of theta is sine, I was using u. Tangent of u is sine u over cosine u, okay? We have sine. Sine we know is minus radical 5 over 3. And I'm going to divide that by, we have cosine too, I think, right? Cosine was given is minus 2/3, or implied given. So this becomes minus 5 over 3 divided by minus 2 over 3, which is minus radical 5 over 3 times 3 over minus 2. 3's will cancel. So that leaves me with minus radical 5 over minus 2, which is equal to root 5 over 2. So we've just found tangent. So this is root 5 over 2. And if you know tangent, you know cotangent. So this becomes 2 over root 5, which is 2 root 5 over 5. This is the answer you have to give, because you can't leave fractions in the denominator. Okay? Questions? Any questions? So we can also use identity. Okay? We can also use identities to simplify trigonometrical expression. Okay? So an example of this, and I'm going to look at your textbook. Let's simplify sine. So example, simplify sine x tangent x. Okay, we want to simplify tangent sine x divided by tangent x. Well, which one of these can we replace? There's probably two ways, or at least two ways this could be done, right? We can replace tangent x, because that's sort of like a given. So sine x stays the way it is. So let's keep that, sine of x. But we know that tangent of x can be rewritten as sine x over cosine x. Okay? And then this becomes, if you multiply sine x times sine x, that becomes sine squared x divided by cosine x. Okay? So that's all I can do with this one here. Or you could have replaced sine x as 1 over cosecant x. So that would have probably, it would look more terrible anyway. So this is how we simplify them, right? When we simplify, we're trying to replace something that's given and see what. So let's simplify this, okay? So what do we want to replace? Do you want to replace tangent or do you want to replace cosecant? Okay, you pick one. This is your problem to work. Well, if you replace tangent, tangent we know is sine of theta over cosine of theta times, this stays the same, cosecant theta, but you can over 1. But you probably can replace cosecant theta, okay? Cosecant theta. So we have here sine of theta over cosine of theta times cosecant. Remember from our identities that we have all the way in the top here, cosecant is 1 over sine. So we can say that this is now 1 over sine theta over 1. And if you simplify this now, we get sine of theta divided by cosine of theta times 1 over sine theta, right? Because this portion here means 1 over sine theta divided by 1 over 1, or divided by 1, which becomes 1 over, which becomes 1 over sine theta times 1 over 1, which is 1 over sine theta. That's how I got there. And now this can cancel with this, which leaves me with 1 over cosine theta. And 1 over cosine theta is the same as secant theta, right? This here, you can't leave your answer like that because there's an identity for 1 over cosine, okay, which is here. So that's how we use the identities to help us simplify. And you have to be very good at the simplification part, because we're going to now start in the next section, or probably today, we'll start to prove identities. Okay? Or I'll leave that probably as a lesson for you to look at. Right, so I want you guys to try this now, simplify this. So try it in your notebook, and then we'll see, we'll work it out together. So as I said, if you don't want to use beta, right, as an angle, if you have a difficult time writing it, you could change it and write theta or whatever. Now, in this problem, we can rewrite what tangent is. So tangent we know is sine beta over cosine beta. So then if you multiply sine times sine, gives me sine squared over cosine beta plus cosine beta over 1. Finding the common denominator, that's cosine beta. So this becomes sine squared beta plus cosine squared beta. But you know from one the identity, right? You know that sine squared theta plus cosine squared theta is equal to 1. So I can replace this with 1. So 1 over cosine is also secant. So final answer, secant theta. Yeah. Questions?
No.
We want to make sure we master simplifying before we can move on to verify, right? So what do we mean by verify? Example, if I tell you that tangent of theta times cotangent of theta is equal to 1. So your idea here is to take one side of this equation. So now we have an equation, right? Please note that now it's an equation, okay? We want to take the left side or the right side and simplify it. Generally, we choose one side to work with. We want to simplify it to show that equal to the other side. And in general, guys, the side that's more complicated, this looks more complex, right? This looks already simplified. So we take the more complex side, and that's the side we try to simplify it. So you want to simplify this, okay? Simplify. And see if you can simplify that and get 1. Well, let's try it together. Tangent theta times cotangent theta is equal to 1. Well, cotangent is the same as what? Cotangent is the same as cosine theta over sine theta, isn't it? And tangent theta is the same as sine theta over cosine theta. This will simplify with this will simplify with this, leaving you at 1. 1 is equal to 1, and here you're verified. Okay? So this is the idea we want to do. We want to show that the left side is identical to the right side. That's the goal. But notice that if you don't know how to simplify, you cannot show this. Okay? So here is one that we have to verify. Okay? An example, tangent x. Okay? We want to show that tangent x times cotangent x divided by cosine x is equal to secant x. Right? Now, which side looks more complicated to you? The left side or the right side? Okay?
Left side.
The left side. So what we should do is try to simplify the left-hand side. Okay? Well, we know we can rewrite cotangent and we can rewrite, or all you have to do is rewrite tangent. If we just rewrite tangent, tangent is the same as 1 over cotangent, isn't it? Cotangent of x times cotangent of x, all of this divided by cosine x. This will cancel out with this, leaving you with just 1 over cosine x. And what is 1 over cosine x, guys? I keep in mind this is equal, so we don't have to write it, but at the end we do. 1 over cosine is the same as secant x. So secant x is equal to secant x. And we've just proved it. That's the proof. The left side must be equal to the right side. Has to be equal to.